Okay, so if we're trying to understand this graph, we can start, okay, we did get a good start here. We first note that if t equals 0, you're going to get 0, right? Okay. If t is negative, this whole thing's going to be negative. And since t is getting bigger in magnitude as you move to the left, you're going to be multiplying this number by a bigger and bigger number. Yeah, so it's going to go down even more rapidly. Now, we're not usually that interested in what happens when t is negative. Okay, when t is positive, well, if we understand exponential functions, just at the pre-calculus level, we understand that any exponential beats any power function. And this is only a power 1 function. So as the exponential approaches 0, it's going to eventually approach 0 much faster than t approaches infinity, meaning that you're going to have an asymptote out here. But as you said, it's going to approach maybe more slowly. Okay? So as t gets bigger and bigger, well, you're going to have something like this, right? Okay? Now, how do you get from here to here? The only way to get from here to here, the simplest way to get from here to here is you go up to some peak and then you turn around, right? Okay? Intuitively, you have to do that. Now, this graph is a little wobbly. It's not particularly well constructed. If I construct it just a little more accurately, it's just going to be nice and smooth, like this. How would you find the maximum value of this thing and the value of t for which this maximizes?
Take its derivative.
Again? Yeah, you do the first derivative test. Okay, so we can analyze this function very easily. The calculus is very simple, and you should do that. Just for practice, it shouldn't take you 3 minutes. And if it does, it's because you need to practice. Okay? You need to refresh yourself on the first derivative test. So whether you do that or not, you know, it's going to depend on a number of factors. Any case, so our x1 will be kind of like this, and our x2 like this. Okay? Now, you could have a case where the initial conditions are such that the coefficient of x1 is 0, right? So you could get this. Okay? How could that happen? You got this harmonic oscillator in some kind of a medium, right? And gamma matches up with m and k so that this is 0, right? So you can think of gamma being big enough to get to this critical value for a given m and k. Okay? Like, how much drag do you need on this pendulum in order to get this behavior? Okay? If you have enough drag, you'll get this. If you have a little more drag than that, well, you get to the other one where you have two decreasing exponentials, right? So what's the motion look like if you have just x2? Now, if you have just x1, and that's also possible, you just have a decreasing exponential. That's perfectly plausible. What would you do to a pendulum to make this happen?